Section 12.2, question 10. The double integral of x cubed dA over region D, where D is a set of ordered pairs x comma y such that x is between 1 and e, and y is between 0 and the natural log of x. Although it's not necessary in this problem to sketch the region D, I'm going to go ahead and sketch it real quick. We know that y is bounded below by 0 and above by the natural log of x. Y equals natural log of x looks like this. Y equals ln x. The x-intercept is 1 because, of course, natural log of 1 is 0. And, of course, y equals 0 is the x-axis. So that's the bottom boundary of our region. Our x's are bounded by constants between 1 and e. 1, of course, is the x-intercept that I mentioned just a moment ago. So there's x equals 1. And x equals e would be some vertical line around 2.7. So our region looks something like this. Again, it's not necessary to sketch the region to do this problem, but it's always nice to have a good visual. As far as evaluating this integral as an iterated integral, because our y is bounded by functions of x, we must set up the dy integral first, which means as an iterated integral, it will be the following. The inner integral will be dy as y goes from 0 to natural log of x. And then our outer integral will be dx, which will go from 1 to e. All right, let's do the inner integral first. Integral from 0 to natural log of x. X cubed dy. X is a constant with respect to y. So integrating that constant with respect to y will just give us x cubed y. Evaluated from y equals 0 to y equals the natural log of x. When we evaluate the antiderivative of the upper limit, we just change the y to ln x. So we'll get x cubed ln x. Minus, when we put in y equals 0, we get x cubed times 0, which of course is 0. So our inner integral ends up being x cubed times the natural log of x. Now we have to integrate this from 1 to e. Outer integral from 1 to e of x cubed natural log of x dx. This is a pretty standard integration by parts. We're going to say u is equal to x cubed. And no, we're not. We're going to say u equals natural log of x. And dv is equal to x cubed. You could say u is equal to x cubed, dv equals natural log of x dx. But the whole purpose of integration by parts is to make the integrand more tolerable. And I think differentiating the natural log to make it 1 over x will make it easier to manipulate. Speaking of which, du will be 1 over x dx. And v, the antiderivative of x cubed, or an antiderivative, 1/4 x to the 4th. So using integration by parts, we have our integral is going to equal 1/4 x to the 4th. So uv, here's the v, times u, which is natural log of x. And get my face out of the corner here. Minus the integral from 1 to e of v du. So 1/4, let's find those things and multiply them real quick. Here's v, and here's du. So we just need to multiply those together to form the second integrand. The 1/4 will stay the same. 1 over x times x to the 4th is x to the 3rd. So we end up getting 1/4 x cubed dx. Our first part was still 1/4 x to the 4th natural log of x minus antiderivative of x to the 3rd is 1/4 x to the 4th. There's already 1/4, so we make a 1/16 x to the 4th, and this is going from x equals 1 to x equals e. All right, let's put in e and see what happens. Let's also partition box off this integration by parts stuff so it doesn't get in the way of the integration. When we substitute e, the natural log of e is 1. And so we end up getting 1/4 e to the 4th natural log of e, which of course is 1, so it doesn't affect the product, minus 1/16 e to the 4th. Here's the evaluation of the antiderivative at x equals e. and at x equals 1. When we substitute 1 into the 1/4 x to the 4th ln x, natural log of 1 is 0, so that part vanishes. Minus, and when we put 1 here, we get 1/16. We do have some like terms up front, so let's get a common denominator. 16, so 4/16 minus 1/16 is 3/16. So we have 3/16 e to the 4th minus negative 1/16, which is positive 1/16, which to me is a perfectly acceptable answer. We could do a few cutesy things. We could merge it into one fraction and write it as 3 e to the 4th plus 1 over 16, since we already have a common denominator. If you wanted to be cute, you could factor out a 1/16. And it's actually not that uncommon to factor out a fraction that would leave the remaining pieces without denominators. But I think the one in the parentheses is perfectly acceptable. I have no ill will against fractions being in answers.